Okay, so here we go. 6-8, day 2. Magic word, conjugates. Everybody say that with me? Conjugates. There you go. Now, before we get into conjugates, I'm going to go to the old basics. We got a binomial times a binomial, so we're going to FOIL it. So first, as x times x plus whatever we get on the outside, which is 3 times x, plus whatever we get on the inside, which is 2 times x, plus whatever we get last, 2 times 3. Notice we get x squared, and then we get 3x plus 2x, which is 5x, and then we get this plus 6. And there would be my answer. See, that's ho-hum. That should not be anything new to you guys, but I want you to notice something. I have the word conjugates written right here, and these are called conjugates. Now, why would they be called conjugates? You'll see the benefit, but notice this is the same as this, this is the same as this, but here it has a plus, this has a minus. We didn't have that going on up here. Here we do. So let's follow FOIL. X times x is x squared. I'm just going to jump to it. X times negative 2 is negative 2x. I'll put a plus sign in there. And I'll put a plus sign in here. Now, inside would be 2x plus last would be negative 4. I want you to really concentrate on the O and the I. Negative 2x plus 2x, they cancel. So I know this sounds a little bit weird, but if you notice they're conjugates, you can fool. You don't have to FOIL. So if you picture yourself on an ACT, SAT college entry exam, time is of the essence. You don't want to waste time, and then you can save time for the problems that are more challenging. So if you go, aha, those are conjugates, you don't have to FOIL it because you're wasting time. You can just fool. So with that being said, I would get x squared minus 4. If I would have just gone x squared minus 4, done. Now, notice we've been dealing with a lot of radicals and a lot of imaginary numbers, and all of a sudden these conjugates are going to come along and try to be of your assistance in a couple of ways. So here's what I'm talking about. If you notice, we have conjugates. This is the same as this. This is the same as this. We have a plus and a minus. These are definitely conjugates. If you notice that, you don't have to FOIL, you can fool. So 3 square root of 2 times 3 square root of 2 is basically 3 square root of 2 squared. And then last, we've got the square root of 3 times the negative square root of 3. So it's negative square root of 3 times the square root of 3. So notice this would be 3 squared, which is 9. The roots fly off, 2. So that would give me 18. And over here, I got a negative times a positive, so that's a minus, and then the roots fly off, 3. So it's really 18 minus 3, biggest subtraction sign you guys have ever seen, which is 15. Now I want you to notice something. The original had radicals in it. The answer doesn't. And that will always be the case when you have conjugates. Where are we going to take advantage of this? We're going to take advantage of it when we have a problem like this. I'm just making this up. And so you guys have had problems where you have to get the radical out of the denominator. So if this was the way the problem was, you'd go, aha, I'm just going to go square root of 2, square root of 2, and then I get 3 square root of 2 all over 2, and I'm done. The problem is, that's not the problem I wrote. The problem I wrote was, I don't remember what the problem was I wrote. So let's go 4 plus the square root of 2. If I say, okay, I'm going to multiply this by the square root of 2 to get rid of it like I did in the last one, notice that's good because the roots fly off, but then this square root attaches itself to that. And it's like, oh, that didn't work. So I hope you were listening to the previous example. I said if you have conjugates and radicals, the radicals are just going to disappear. So what I would do is multiply this by 4 minus the square root of 2, 4 minus the square root of 2, and see that I get 12 minus 3 square root of 2 all over, and I go, hey, I can fool. So that'd be 16 minus, and then the roots fly off, 2, which is 14, and because there's no number that can go into all that, you're done. Notice, we multiply by conjugates, and we got her done. Now, these problems are going to be a little different because it's going to have an imaginary number, but the concept is the same.